This isn't a motorcycle. It's a sealed, all-weather machine built to beat the storm. And this is the man behind it. Meet Benny, a former satellite engineer, now full-time problem solver. In his garage, there's only one rule. If you can dream it, you can build it. The success of his next project hinges on one critical part: the wraparound canopy. To form it, he needs an industrial thermoforming machine that has a $100,000 price tag. This is completely out of budget, so he'll build the whole factory in his garage using hardware store parts and an engineer's brain. And there's one final twist: a hard deadline. Benny has committed to unveiling the finished machine at the country's biggest motorcycle festival just 90 days from now. The clock is ticking. Can one man pull this off? Before building the canopy, Benny needs a motorcycle. He starts by recycling the modified frame from a previous project. The first job is reassembling the rolling chassis. After 2 days, the bike is whole again, ready for transformation. Benny paid $3,000 for it. It's the first expense in a budget that will be pushed to the limit. To fit the canopy, the rider's position must be lowered. His solution is to remove the entire rear support structure of the seat. It's a major change to the bike's core geometry, requiring new, custom-fabricated mounting points. This is where his years as a machinist are critical. One wrong move could compromise the entire chassis, turning his $3,000 investment into scrap. The modification makes the factory seat unusable. With the frame permanently altered, the original part must be cut and reshaped to fit. "10 days of work are gone just to create the foundation. And the real challenge is yet to come. Benny needs a machine that can shape plastic on an industrial scale. This process is called thermoforming. The principle is simple. Use heat to make a plastic sheet pliable, then use a vacuum to shape it over a mold. This factory machine costs over $100,000. For a lone engineer, this is far beyond budget. So he's left with one option: build the entire factory himself. It all starts with the mold. The final canopy will be an exact copy, so any flaw in this master pattern will be permanent. He first builds the skeleton of steel customized for the bike's frame to ensure an ergonomic fit. From there, he builds up the raw volume with layers of expanding foam. A fast and resourceful way to create a large, lightweight core. To sand the complex curves, a standard tool won't work. So in true Benny fashion, when the perfect tool for the job doesn't exist, he improvises his own. A hard, two-part body filler is applied to create the final, durable surface. This is the most painstaking part of the process. For 6 days, he has been racing against time, working 15-hour shifts to sand the mold perfectly smooth. All that work for a single piece. And this is just the first step. Now comes the next stage of the build. Time to build the thermoforming machine. The heart of the thermoforming machine begins here. A $600 old trailer that will serve as the foundation for a custom factory oven. "20 days of the project are gone, almost a full month out of the 3 months he had initially. With the festival deadline looming, the calendar itself is now the enemy. The entire interior is lined with reflective foil, ensuring every degree of heat is trapped and focused on the plastic. To produce that heat, he turns to an unlikely source. He's gambling that 10 simple household heaters can deliver the thermal energy required to mold plastic. With no multi-million-dollar budget, talent and ingenuity are his most valuable assets. The heaters add another $300 to the cost, pushing his total investment to almost $4,000 already. It's a massive electrical load. One bad connection could mean a catastrophic fire. To manage the risk, he splits the 10 heaters across 5 separate circuits. With the flip of a switch, his homemade oven comes to life. 12,000 watts of power ready to be unleashed. But the factory isn't finished yet. With the oven ready to heat the plastic, it is now time to build the separate machine that will shape it, the vacuum system. Its job is to create a powerful suction force strong enough to pull softened plastic over a mold and capture every curve. The table has 2 levels. The top is where the mold will sit. Below is where the engine of the machine will be stored. A small vacuum pump alone isn't nearly powerful enough, so he connects it to 3 massive tanks. Materials for the vacuum system aren't cheap, and just like that, another $1,200 have flown away. Building from scratch has a price, and it's rising fast. Here's how the system works. First, a pump sucks the air out of the tanks. They become a vacuum, desperate to pull air back in. When the valve is open, the suction rushes through the table and pulls the hot plastic tightly over the mold, shaping it exactly. Finally, he needs to prepare the platform where the mold will be placed. A rubber gasket is laid along the edge, designed to create an airtight seal. He then drills a grid of holes. This is where the suction will come from, pulling air straight down through the table when he opens the valve. Between the oven and the vacuum system, our engineer has spent another 22 whole days working, leaving just 48 days until his deadline. There is no slowing down. This small garage is about to test Benny like never before. The final component has arrived. A 4mm sheet of polycarbonate destined to become the canopy for his motorcycle. At $400 apiece, every single attempt carries a heavy price. Now, it's all about the last details. It's been nearly 2 months of work to get to this point, thousands of dollars invested, and a constant race against a deadline that gets closer every day. It's time to see if his theory holds up. The sheet is loaded into the oven, and the heaters ignite. Catastrophe.
No, nothing.
Weeks of preparation turned to scrap in less than a minute. The first major test has ended in complete failure. And the damage gets worse. The master mold cracked. But for our man, this only means one thing: time to get back to work. Every new layer of body filler needs hours to cure, a costly delay that eats into precious time in an already tight schedule. Analyzing the wreck, he realizes the oven didn't produce enough heat to make the plastic pliable. To solve it, he brings 5 more heaters, boosting the oven to a total of 15. He will also cut the oven in half to reduce the space between plastic and heat, and then he will hang the entire rig from the ceiling. Heating from above cuts the transfer time, preventing the plastic from cooling before the pull. Benny now has less than a month to re-engineer the entire thermoforming machine and make it work. As he reinforces the frame, he spots a critical flaw. A triangular gap that is acting like a chimney, letting precious heat escape. To maximize the oven's efficiency, he seals the opening, ensuring the chamber is completely airtight. The deadline is no longer a distant goal, but an immediate threat. And he's running out of money. New heaters, redesigned materials, and another plastic sheet on the way have pushed the cost up by another $700. The new heater setup is working perfectly. With that sorted, it's time to flip the chamber upside down and suspend it from the ceiling. It's a risky move. If the ceiling mount fails, hundreds of pounds of steel and 15 live heaters will come crashing down, wrecking the entire mold below and endangering everyone in the garage. Any more setbacks could mean running out of resources to finish the project, and no motorbike to showcase at the festival. The oven has been cut, sealed, and supercharged with 15 heaters, and the entire rig now hangs from the ceiling. This isn't just a second attempt, it's a completely new machine. And after the first frame cracked, this new one is built tougher, reinforced with steel. The new sheet of plastic has arrived. Time for round 2. 14 days left. Another disaster. After 2 failed attempts, he changes to a new material, acrylic. It softens at a lower temperature and stays workable for longer. The sheet took a full week to arrive, leaving just 7 days left. His nerves are shot. If this fails, he won't make it to the festival. The pull is clean, no rips, no wrinkles, but the shape is too shallow, unusable. Instead of giving up, he tries a desperate move, reheating the same plastic and firing the vacuum a second time. They might have something promising here. The victory is short-lived. The mold is too small for a person to fit inside. The clock has beaten him. After months of relentless work, the anti-rain motorcycle is not ready for the festival. He's frustrated, but refuses to arrive at the festival empty-handed. Instead, he decides to bring an old creation of his, a custom-built motorcycle. The festival was a success. Attendants loved his vehicle, a much-needed victory after weeks of exasperation and expensive failures. But the anti-rain bike is still waiting in the garage, and he is determined to finish it. After repeated failures, Benny is forced to consider a radical approach. The mold is too tall for the plastic to ever fit the whole contour. He must cut apart the mold he has spent weeks perfecting and commit to a new 2-part design. This will completely change the motorcycle's design he had in mind, but he is convinced he can make it work. The festival deadline has already slipped by, buying him time but not relief. His budget is in ruins, and he has seriously considered quitting. But his decision is final. He is going to give it a last chance. For this all-or-nothing attempt, he wants to cover all the bases. He attacks the one remaining weakness, the suction system. His current vacuum pump is like trying to drain a pool with a garden hose, far too weak. Before risking his final sheet, he upgrades to a heavy-duty compressor and runs a trial. The result gives him hope. Now, the final attempt begins. A perfect pull. The plastic snaps tight over every contour of the mold. The journey here wasn't easy. A factory machine born from an old trailer. 3 failed attempts. Weeks lost. Thousands burned. Nights spent on the edge of quitting. And yet, he never stopped. Could this be the moment it all pays off? Against the odds, he has done it. At long last, success. The dream is alive. But there is no time for celebration. The project isn't done. This was not the initial plan. A two-part canopy creates a brand new engineering puzzle. How to join them? Once again, Benny is forced to invent. He begins by fabricating a flat strip that will lock the two halves together, creating the needed space for the rider inside. He fabricates aluminum edge rails, rolling them to perfectly match the canopy's curve. They will act as the spine, locking the new center panel to the outer shells. The metal frame acts as a structural brace, preventing the side window from flexing under wind pressure. It is what truly holds everything together. Dozens of small, custom-bent L-shaped brackets will be placed on the inside, locking the three panels into one solid piece. Now, it's about assembling it all to create the long-awaited canopy. For this part of the build, Benny had to buy pieces and materials that add another $250 to the bill. Finally, the canopy is complete, and he can move on to the final assembly. For the first time, the two halves of the project, the motorcycle and the canopy, are about to become one. He starts by making the mounting points. If they fail at speed, the result would be catastrophic. So before anything, he needs to reinforce the front, making sure it will sustain the canopy's weight. The fairing has to be cut apart to make room. He designs a custom spring-loaded mechanism to secure the canopy. The first test reveals a flaw. The canopy collides with the bike's bodywork. A quick, decisive cut with the saw provides the needed clearance. For the new mirrors, which he bought for $70, he fabricates a custom bar that will push them out wide enough so the rider can see the road behind the new bodywork. The main structure is complete, but gaps remain where the custom canopy meets the bike's original bodywork. Time to solve that. Using a heat gun, he forms each filler panel by hand, pressing the hot plastic against the bike's contours to create a perfect bespoke fit. At the rear, a locking mechanism is engineered in metal, clamping the canopy shut with a solid click. It can be released from inside or out, giving the rider full control. And finally, a roof light is installed, adding $50 to the total cost and closing the final bill at $7,490. After 4 months of design, the anti-rain motorcycle is no longer a project confined to the garage. It's a finished machine, ready for the ultimate test, the open road. It began as a simple question. Can one man in his workshop build a machine to conquer the rain? An idea that demanded more than just skill. It demanded resilience. And now, it's time to test it.
We're in a rainy day, guys, and we have nothing. You see?
As the rain falls, the world outside is a blur of water and spray. Inside the cockpit, the rider remains perfectly dry. The theory has been tested, and Benny's vision has come to a reality. The custom-built canopy opens and closes effortlessly, and the homemade latch he engineered holds firm. This isn't just a prototype anymore, it's a fully functional machine. The journey wasn't easy. It was measured in countless hours, many tests, and costly failures. There were points where he almost gave up the project. The result now lives and breathes on the open road. A machine that deflects the wind and sheds the rain, performing the exact function for which it was conceived. This is the very essence of pure invention. It isn't about multi-million-dollar labs or massive teams of engineers. It's about the rare genius required to not only design the final product, but to first build the factory that can make it. This machine is the result, a powerful reminder that the most groundbreaking ideas often come not from a boardroom, but from the focused, brilliant mind of a single creator.